So we now move on to the final talk of the plenary State of the Art session, and that final talk is Cam McQuaig on exploration targeting. Cam graduated from Lakehead University, followed by a PhD in geology from the University of Saskatchewan. He then enjoyed 10 years with SRK Consulting, becoming a director of the Australasian practice. In 2005, he became the inaugural director of the Centre for Exploration Targeting, CET, at the University of Western Australia, undertaking applied research with the minerals industry focused on the science of exploration targeting and building the next generation of mineral explorers. Under his leadership, the CET built a team reaching a peak of 90 staff and students and undertook $60 million of research on projects spanning 6 continents. CET research outcomes directly impacted on resource-based growth for partner companies, led to commercialization of targeting tools, and provided the technical basis of 2 new exploration companies. Cam was a major founding member and co-author of the Uncover initiative in Australia. In 2013, Cam was awarded the Gibb Maitland Medal from the Geological Society of Australia for contributions to Western Australian geology and mineral resource exploration. In 2016, Cam joined BHP Billiton as principal geoscientist in their internal geoscience Centre of Excellence, providing expert guidance on mineral systems across all scales to help maintain and grow a high-quality resource base. His career has taken him to 41 countries on 6 continents, working in a wide variety of mineral systems, from Archean to Neogene in age. Cam.
Thanks, John. And I'd like to thank the organizers, first off, for inviting me to speak to you today, and also to acknowledge my co-author, Ross Sherlock, newly minted director at Mineral Exploration Research Center at Laurentian. So what Ross and I are doing today is not giving so much a backwards look in terms of where we've come in the past decade for exploration, but really, what's the framework we're going to have to grasp in terms of finding mineral resources into the future. So Paul Agnew, in his talk this morning, set up quite nicely the challenge with declining discovery rate over the last decade. If you actually look at the graphs that Richard Shoddy does that shows quality of ore body, it's even worse, right? So that what we would call tier 1 ore bodies, and there are ways to define that, that trend, that declining trend is even more drastic, and it's across all commodities. So the challenge we have is that we all want high quality resources, and we know if we find a really good deposit, that small, or an awesome deposit, smaller good deposits cluster around those often. So how are we going to do that area selection? And that's the challenge I want to talk to you about today. So I'll talk a little bit first about a philosophical framework in which to view the challenge, then look at a couple of examples that I've taken from petroleum and copper to show how putting that type of thinking into action. So first of all, I'm a fan of putting takeaway messages at the front, as was one of the previous talkers. So if you do decide to fall asleep, you'll wake up to the exact same slide at the end, so it's good. Number 1 in exploration, you have to know what you're looking for, and that will be different for everyone in the room, right? In terms of what your size hurdle is for your particular company, what is exploration success to you? And I can't emphasize enough the importance of scale. Scale is critical. When I find 2 geoscientists, both well-informed, both with experience, arguing about what's more important in exploration, often they're both right. It's just they're talking at different scales. So it's important to know where your decision point is in the scale of the exploration process. So you have to marry your understanding of the mineral system to decision points in your business. You got to marry the science to the business decisions and to the scale of the relevant geological processes. And because of that, and this is something that we don't capture well when we do, say, automated prospectivity analysis or even manual targeting, is targeting is hierarchical. It's a sequential volume reduction from the scale of the planet till you get down to the money pot. And it means that at each scale, you actually have to undertake different prospectivity analyses, looking at different things. You can't just poke the ore body in the eyes right on from the first go. I'm going to talk a little bit about balancing empirical and conceptual targeting, and a little bit on monitoring residual endowment. I think that's really important and something we miss. You know, like we say, oh, we're going to go where there's big deposits and we'll find more. Well, yes, that's a well-endowed belt. Yes, there may be more big ones. But as the geostatisticians would tell you, or statisticians would tell you, you're sampling without replacement. It's not what's been found, it's what's left to find that's critical. So how do you monitor that or make an estimation of that? And I'll cover a few more things in that. So on this slide is just trying to put some context around the challenge. And what it shows is on the y-axis, it just shows the relative inputs or relative effectiveness across scales, from broad regional scale, and you can make that however big you want to the scale of the planet, down to the scale of actually an ore body or an ore chute within a mine. And it shows the trade-off between prediction technology and detection technology. So prediction, where we're taking a concept around whatever available data at whatever resolution, quality, scale, and then making a call as to what data to go collect in the next space, versus direct detection, where we're actually doing much more systematic, if you want, empirical exploration. And the key thing is that at the ore body scale, or even at the deposit to camp scale, we've got a lot of weapons to bring to the problem. And I've just listed a few there. And when I look out in the trade show, there's a lot of stuff on offer there. Fantastic science, fantastic ways that science has been translated into tools, and fantastic ways that those tools are built into workflows, okay? And we're arguing about being optimal in doing that, that's fine. But the problem is, or the challenge is, when we get out to the larger scale, the amount of actual detection technology we have dramatically drops off. And so at the scale, for example, of the Superior Province, I have no detection technology for the next gold deposit or nickel sulfide deposit or VMS deposit that I can systematically apply cost effectively at that scale. So how do I make those types of decisions? So the real challenge in exploration is what weapons to use, yes, but where? Where? It's the area selection is the key thing. Where am I going to go employ the technologies? So you can marry that across, you can divide that scale up into business decisions, essentially, and area selection decisions. So if I'm making a decision at a very big scale, I'm saying, where's the next basin I'm going to go explore in? Where's the next arc? Where's the next arc segment that I'm going to go look at? And make a choice there. Then when I've made that decision and prioritized those areas, I'm thinking, where's the next cluster of mineralization, the camp, where I've got potentially the chance to get a lot of good deposits or a couple big ones. And then once I'm in the camp, my next decision is, right, where am I drilling? Where's my actual ore body? And I'm out to find the ore body now. In the first ones, I'm actually not trying to poke the ore body between the eye in the first two boxes. I'm just trying to narrow the search space to focus my limited people, time, and money, right? And so in red on that diagram is the aspects of flexibility of your exploration program and the direct costs. So when we're making decisions as an industry about where to explore at the left side of that diagram, people say, oh, that's pretty low risk because you're not spending a lot of money. And it's true, we're not incurring a lot of direct costs. But the opportunity cost is massive. Because if I make that central decision right, I can do a lot of things wrong down here and still find the ore body. If I make this decision wrong, I could execute perfectly using the best tools, the best workflows, but it's just not there to find, right? And even though I'm here representing BHP, right, the world's largest mining company, we still have limited people, time, and money. We can't go all over the place and do that. Where do you focus? And we had a little bit of a talk yesterday about things like, once you make that decision, you open a whole world of hurt, right? You've got things like permitting, getting on the ground. Now you've got people on the ground. Now you are employing these weapons in anger, and they cost. They come at a cost, right? So your costs skyrocket, and your flexibility plummets. So we have to make that decision best. And then I've got at the bottom just aspects of some key things to consider. You know, growing the right to explore in an area versus the period where you're actually trying to capture what you think is the most prospective ground, and then building and growing that right to be there afterwards. This is pre-competitive data. You're largely using government data, stuff in the literature, stuff that's publicly available essentially, through to by this time, you're collecting your own primary data sets, primarily here. This is much more of working in a strategic context. By the time you're down here, you've got a very fast information flow and you're working in a tactical space, although under a strategic umbrella. And probably the hardest decision is this one. When do you actually decide, no, based on the information I have, based on the science I've got behind this, we got to move on. We got better things to do with our money. A little bit on empirical and conceptual targeting. If I took explorers in this room and actually did some sort of profile of you, I'd probably be able to split the room into a bimodal kind of distribution here with tails coming towards each other in the middle. And the people on one end of that spectrum, the empirical versus conceptual spectrum, often look with disdain at people at the other end of the spectrum. And it shouldn't be that way because they actually do two different things. They're entirely complementary. What empirical exploration does is people following patterns in data. But following a pattern in data can be good, it could be bad, because it could be a spurious correlation. And it's only really, you're only really confident in using an empirical exploration method when it's underpinned by an understanding of process. So when you see an emergent pattern in a large data set, and we're getting it fast and furious now, these big fire hoses of data coming at us, right? When we see that emergent pattern, it should make us ask, why? Why is that pattern there? What's the underpinning geoscience process that's creating that? Conceptual is different. Conceptual says, given my understanding, although albeit incomplete and imperfect, given my understanding of a mineral system, at this scale, this is what I need to look for, and this is the next data set to go map it, right? So one's telling you what's the next data set that's the maximum leverage for your decision. The other one's providing you a better understanding of the system. So if they work together, they're optimal. The strengths and weaknesses are up there for you to read. On the empirical side, definitely data limited, a lot of stochastic bias, right? And there's those types of limitations. On the right-hand side, this can lead you to the previously unrecognized expression of an ore deposit. It may not look like the analogs we've already found, which is a big advantage. The problem is us. It's the systemic bias and the human bias and heuristics that we bring to the challenge. So just some examples of empirical, just to point it out. Examples of early from the 1960s onwards, lineament mapping. Some of these now we know are actually real lineaments. We can see them in multiple geoscience data sets. This was obviously in coarse data at that time. Some of them, though, are spurious. Correlation closer to home here, correlation of gold deposits with breaks or major structures in the Abitibi. But why? You know, what's the process behind it? What's the source of gold? These are types of questions that still are out there in terms of understanding the process. Conceptual, we're getting much better at understanding how these systems form, though we're still a long way from fully understanding them. A good example, again, close to home, VMS deposits. Why? Because we can actually see modern analogs on the seafloor. We're starting to understand how they form. We're understanding geodynamic environments that they're in, where they would be preserved in older origins. And so that's something we can take into targeting. In the last 15 years, there's been significant advances in understanding porphyry systems to the point where we are being able to target and narrow down large search spaces. Whoops, sorry. Because we understand the process that by ponding magmas deep, I can take any calc-alkaline magma, doesn't have to have a special starting composition. If I treat it right, I can make it copper fertile, and if I don't, it won't produce a big system. And these are things that we can now take into whole rock chemistry and now into mineral chemistry, as Paul was pointing out, to use this for area selection. So the key thing is from a conceptual point of view, is being able to break down your mineral system across scale. So that is, what are the critical factors? So there's that original diagram, so from large regional to deposit scale. What are the critical processes that have to happen for your commodity of interest to concentrate in a big economic concentration? And all of these things will probably be relevant to your system. You may call them some other name, but fertility, source. I need a source of the metal or the commodity and some transporting agent to move it, a magma, a fluid. Right? I need a geodynamic trigger. I need some moment in time that turns the Earth's geological system into a mineralizing system for a short period of time. Right? So what are those moments in time? What causes them? I need an architecture, pathways for that transporting medium to move through the lithosphere at whatever scale. I need to actually concentrate the commodity of interest. I need to take it out of the fluid, unless it's petroleum and I just want to trap the medium itself. And I need to preserve it and maybe even upgrade it at a level that I can economically exploit it. All of those things need to line up. But different things matter at different scales. At the scale of selecting, of the deposit, I'm actually worried about where's the best site for metal deposition, right? And that's where we're comfortable in targeting. At this scale, I actually don't care. I'm not worried about the metal coming out of the fluid. I just want to know, was the fluid even there with the metal in it, right? That's what I need to predict. So at a big regional scale, that's what you focus on in targeting. You don't worry about this stuff. But if you look at any prospectivity analysis, pretty much, you will find that even at very big scales, processes at the site of deposition are heavily weighted, or at least equally weighted in the prospectivity analysis. And I would put to you that that's flawed. This is just putting that into an empirical sense. For empirical targeting, we've actually got lots of data. So down here is a place where we really should be doing a lot of empirical targeting, taking machine learning into these big data sets, finding emergent patterns that help us understand the process and point us to analogs. We're making some progress at this scale. So that's the scale of targeting a new camp. But now we're starting to get into big disjointed data sets, variable resolution quality. And down here, we're struggling. It's usually too big a scale to do a lot of systematic empirical. So I want to take a quick look at the petroleum industry. They also have this mix of conceptual and empirical targeting, but they are much more willing to put money after a concept. And you say, why? Well, there's a couple of ones. People say, oh, it's more expensive. Oil's a different business. Really? Right? Iron, coal, nickel, copper, they're all different businesses, right? It's not really that different, right? And also, going more towards better detection or imaging technology is a path that some petroleum companies went. They didn't go petroleum systems, they went that way, right? Do they have an undercover challenge? Absolutely. Nobody goes around looking for oil seeping out of the ground anymore, right? And they haven't for decades. And so now it's very heavy geology, geophysics, usually in offshore areas for conventional petroleum. Do they understand their geological system better? Absolutely. So even though petroleum's a complex system, they have a much better understanding of it. And because of that, they're willing to risk capital on the concepts, but they do so knowing exactly the science they need, the next data and bit of knowledge they need to make the next scale of business decision, right? And they'll pin it on that. So just an example from BHP Petroleum. That's the production profile over time, BHP in terms of thousands of barrels of oil equivalent per day. And internally, they've defined Tier 1. This isn't industry standard Tier 1 in oil, but this is a internal Tier 1. They identified as 100,000 barrels of oil a day. Net to us is a Tier 1. They said, well, then if we do that, we need to have multiple pools of greater than 250 million barrels of oil in a basin. We're only going to get about 20% of it generally because we risk share in the petroleum industry. And therefore, I need to be in a basin that has 5 billion barrels of oil. So if I'm going to enter a new basin for conventional petroleum, I have to see the potential for 5 billion barrels of oil in that basin. Otherwise, I'm less certain that that's the place I want to be. And even though there's a lot of science that goes behind this, they break it down to just a few key things. Source, a place to trap the oil, and that's it. But also, they look at where has value been captured over time in a lot of basins. And this is the same in minerals, by the way, and I'll show you an example later. This is called a creaming curve. So the idea is that if you look at the number of discoveries over time versus amount of the resource added to the total inventory of that geological region, the vast majority of the value is captured earlier. So if you're a late entrant into a basin or for us, a mineral district, right, there's proportionately less value to capture. And they say, well, now the cream's been taken off the basin, like with milk, right? You don't want to just have the skim milk left. They take an approach that goes right from looking at plate tectonics, basin evolution, sedimentation patterns, the thermal history, right down to how do I get the oil to separate off the grains, right? Plate to pour, that's the mantra. And relies on the science, doesn't compromise on data scale or quality because they know the data and the knowledge they need to make the next decision. But when they do their targeting, different things matter across different scales. So these are the three things that are important. This is just measuring their effectiveness. At the big scale, it's just about, do I have a world-class source rock? And if I don't care if I have the best reservoir in the world, the best trap in the world, I'm not gonna go in there. By the time you're down here, it's about what's the volume, rate, quality of hydrocarbon I'm gonna produce. And they've got an equation that puts that through to value. So let's go back to minerals. So this is the reason I put this picture up is that this is a picture of the Rover Boys, which was a team hired by Exxon to go around the world looking for oil seeping out of the ground, essentially. But they're actually doing more than that. They were doing basin analysis, but onshore basin analysis. It was the last big wave of exploration for onshore conventional reserves. This guy sitting down here is interviewed at that, I'd go to that website. He's 90 years old, he's still working, and he saw the transition. He's lived through the transition of going from onshore to just offshore to deep basin, and how it's gone from a lot of field geology, living off the land, through to integrated geology, geophysics offshore, done remotely from an office in Houston or whatever, right? And in minerals, various companies are variably along this path, but we're pretty much on the early stages of that journey. So, copper, know what you're looking for. Know where there's a cost curve with the BHP assets as of last August. Know where you want to be. Look at the project pipeline, and this is all them by Richard Shoddy, by various stages, and all of those in exploration, looking pretty on the line, right? And that's the issue, is the project pipeline in the world, the quality of it, is not fantastic. So it pushes you to an exploration space about you need to be discovering. And so you have to define what is it you want to look for. What is it that's going to make tier 1, 5 million tons of contained copper, for example, minimum grades for various operations. And that helps define your search space. So said copper, there's the map from our database on said copper occurrent or deposits around the world. The problem, 5,000 basins in our petroleum database, and that doesn't even honor a lot of the Paleoproterozoic and Neoproterozoic ones. So how do you narrow the search space? And first of all, about 1,500 are offshore, so that helps. We're not looking offshore yet for the said hosted copper. But you need a system, right? So undertake the analysis at this scale and have a go at what you can map at this scale, even though you can't systematically evaluate it. And that's the result. So this is 180 basins prioritized, looking at where they sit in the regional criteria, most important, versus district criteria. And note that copper endowment was not a criteria in the analysis. So endowment is the circles. There's a number of basins that sit here that are looking pretty good, but there's not a lot of known copper endowment. That's the first mover advantage. No one else has found a big deposit there yet. It's not saying there is one, but at this scale, it has all the earmarks of being fertile for a big system. Monitoring endowment, again, the creaming curve concept, so that all the value, or a large percentage of the value, is captured early. So you need to be a first mover, so you need to be able to monitor that. This is for the Zechstein. I could show you the Central African Copper Belt, which goes like this. And then what happens? Kamoa, which resets it. Why? New play in petroleum speak, a new play in the basin. You can also discretize it. If you look at size frequency distribution, these often, in mineral districts, often follow power law relationships. And so you can discretize to say, really, does the size of the prize remain? And people often say, well, that's something I could have used 40 years ago. So we went back 40 years. And then we did that in the Yilgarn, where we could look at gold in the Yilgarn over time. And you can use this as a tool to say, is this still a place that has the size of prize with the appropriate probability of discovery for our company to be involved there? Whoops. So the key thing, know what success is to you, and monitor residual endowment. Just because you're in a really well-endowed belt doesn't mean you have a good chance of finding a good deposit. In fact, it might be worse. You have to look at how well explored is that search space. And I guarantee you in a lot of the world's mineral belts, the opportunities are really undercover in those belts. So there'll still be opportunities there. And just one last thing on this has come up and been covered by others, so I won't do a lot on it, but just the idea of being able to do the data mining. And more we're going to be able to use machine learning to find the emergent patterns. That helps us understand the question, what data we need to map the system. Once we get that data, we can iterate through that loop. So I think there's a lot of learning that will come in that space, combining empirical and conceptual targeting, so that essentially you can have a process of how to go from global to deposit scale and assess all opportunities and contexts and be quite proactive in that space. And I'll leave it on that last slide, which you saw already.
Great. Thank you very much. Seeing as how that was the last paper of the session, we will make time for a couple of questions if there are any.
There is a little bit about that. I mean,
Could you just briefly summarize the question?
Yeah. Why is the tier 1 dropping? Was that because people went away from risky jurisdictions back to known areas where essentially there was no more tier 1 to be found? That's partly it. So that where there are significant new tier 1 deposits essentially sticking out of the ground, and we acknowledge they exist, right? A higher proportion of those are in risky jurisdictions. But just basically, over time, we've gotten really good at finding ore bodies if they stick out of the ground or stuck out of the ground at some point. And mankind for thousands of years has been getting better and better at it, right? And just when we're starting to get really good at it, that search space is really rapidly diminishing. Although there's deposits to be found in exposed areas, a lot of the potential is undercover. And that brings up a whole new, once you go under just tens of meters of cover, that makes it blind to past exploration techniques, your expense just skyrockets in trying to detect and delineate these ore bodies. So I think that's what that declining search or declining discovery rate is telling us. The search space is depleting.
Okay, we'll take one more question if there is one here.
It's a good point. I think the decision really is about, it isn't about walking away and I think there's a fear of walking away, summarize the question. The question is exit strategy. How the decision to hold or fold. Okay? And it really comes down to the company and knowing what success is, but also there's a big fear of walking away and someone else will find the deposit. And we actually have to break through that. What we have to be able to do is to say, given what we know, and we understand it's imperfect, but given all the thinking we could do, the empirical and conceptual area selection that we do as best we can, we think that this opportunity isn't as good as this opportunity, and therefore we have to let that one go, right? We've got better things to do with our money, right? Now, at the end of the day, that may not be the right decision, right? But you did it for the right reason, right? And that's the only way you're going to learn, right? Now, if someone comes and finds a deposit there, and you missed it, you say, okay, you have to do a postmortem and say, why did we miss it? What was it? What is it that we didn't understand? But you can't have that fear of it. You got to move on and have a learning loop in there.
Okay, thank you very much again, Cam. And with and with that, we'll close the morning sessions. Thank you all for attending, and we'll see you all back here at 2 p.m. for the panel discussion on integrating the geosciences.